we need to figure out, well, wait a second. Isn't there a whole nother quadrant where the ratios are positive? So we just figured out the sine of x is equal to 1/2. And so we found an angle from the first quadrant that works, which was 30 degrees, right? So at 30 degrees, we have a sine ratio of 1/2. So I'm going to look here and be like, yes, right here at pi over 6, I have a sine ratio of 1/2. So is there any other place besides quadrant 1 that the sine ratios are positive? So remember, we can use our old friend, all students take calc. And I remember that the other quadrant that sine is positive in is quadrant number 2. So we're going to call this the secondary angle. I can see that sine is positive in the second quadrant at 5 pi over 6. So we can say a secondary angle, another angle that works, is 5 pi over 6. And what quadrant did that come from? Quadrant 2. Okay, so sine has two answers for ratios that are positive. Ratios that are positive will come from the first or the second quadrant. What about sine ratios that are negative? They will come from the fourth or the third quadrant. Okay. And then we have to think for a second, like, okay, so there's two answers for every ratio, two angle answers for every ratio. But actually, what if I said, is pi over 6 the only angle that's going to lie in the first quadrant that's going to give me a ratio of 1/2? What about a coterminal angle? So adding 12 pi, giving me 13 pi over 6. Oh my gosh, yes. So we also have coterminal angles. Okay, so all of our coterminal angles. So let's start with quadrant 1, which was our principal value. We had x is equal to, right here, x is equal to pi over 6. And then for our coterminal angles, we say plus 2 pi n, where n is any integer. Okay, so we'll talk about that in a second. Okay, from quadrant 2, so that's one answer. From quadrant 2, we had x was equal to 5 pi over 6 plus 2 pi n for coterminal angles. So this 2 pi n takes care of my coterminal angles. And then again, it's the same where n is in any integer. So whole numbers, positive or negative. Okay. And these two equations give us all the possible angle measures that would give us a sine ratio of positive 1/2. I know, it's crazy. Okay, so I'm going to give you some tips and tricks really quick before we start solving some for realsies. Okay, so tangent. We're just going to look at all students take calc really quick. And we're going to remember that the principal values come from the first and the fourth quadrant. So if right now in tangent, tangent ratios are positive in the first quadrant and the third quadrant, and they're negative in the fourth and the second. So If my ratio is positive, it's going to come from one of these two quadrants. If it's negative, it'll come from one of these two quadrants. So the principal values. Okay, so the equation for if x is the angle, we're going to get some sort of angle from our calculator. I'm just going to call it theta. Okay, plus 2 pi n. Okay, now across from, let's call this a 1/2 and root 3 over 2. So if I have negative 1/2 and root 3 over 2, the nice thing about tangent is that the two answers that I get are always supplementary. They're always 180 degrees away from each other. So I can just add 180 degrees to get to the next answer. I can add 180 degrees to get to the next answer. So for tangent, we actually don't use 2 pi n. We just say plus pi n or plus 180 degrees times n. So depending on if you're in radians or degrees. Okay, so we don't need a secondary equation, whatever your principal value is. That's what I should write instead of theta. I'm going to write the principal value from your calculator plus 2 pi n. So the principal value, again, comes from the first or the fourth quadrant. All right, so sine, that its principal values also come from the first or the fourth quadrant. Sine is positive in the first quadrant, it's positive in the second quadrant, and negative in the third and the fourth. So if I have an answer, if I have a principal value in the first quadrant, then I am going to have a secondary equation in the second quadrant. Likewise, if my principal value is in the fourth quadrant, then where will you also have an equation? Where sine is negative, in the third quadrant. This is how we get these answers. You go x is your angle, or your input is equal to the principal value plus 2 pi n. And that takes care of, this part takes care of your coterminal angles. Okay. For the secondary equation, so either from the second or the third quadrant, we use the same equation. It's going to be pi, so 180, minus the principal value. Okay, that'll give you your secondary equation plus 2 pi n. Or, if you're in degrees, 180 degrees minus the principal value plus 180 degrees n. Again, the part in yellow takes care of the coterminal angles. So all of this takes care of coterminal angles. Okay? All right, next up, cosine. So cosine is principal values are in the first and the second quadrant because cosine is positive in the first quadrant and the ratios for cosine are positive in the first quadrant and negative in the second quadrant. They are negative in the third quadrant and positive in the fourth quadrant. So if I have an initial principal value that ends up in the first quadrant, the nice thing about cosine, so your calculator, the prime principal value is going to be from the first quadrant or the second quadrant. Your calculator will tell you exactly what the value is. And then I'm going to have to just add the 2 pi n for all of my coterminal angles. Okay? For this secondary equation, notice your secondary equation is just a reflection of the triangle from from the first quadrant. So this angle right here is just negative your principal value. That's it. So to get the second set of answers, we do negative your principal value plus 2 pi n. And again, those take care of your coterminal angles. All right, so the steps. We isolate. All right, this is going to make no sense at all, but we're going to do a bunch of problems to highlight how to do these because it's like, it doesn't look like a lot of steps. It's a lot of steps, okay? So first we're going to use inverse trig to solve for our input. Then we need to find our principal values and then add 2 pi n. And then we're going to calculate the secondary value just like we did using the rules I gave you, and then add 2 pi n. And then sometimes we have to do steps 4 and 5 where we, like, maybe there's some more isolating we need to do. And then if your equation gives you a domain restriction, like negative 2 pi is less than or equal to x and is less than 2 pi, then we actually have to list out all the possible answers. Right now, from steps 2 and 3, that will give you all possible solutions if there was no restrictions on your graph. Okay, so I am going to pause there and we're going to do examples next. Okay, welcome back. We're going to solve trig equations for real Z now, now that you had an overload of information. So we're going to start with this one. Sine of x is equal to negative 1/2 x. The first thing we need to do is isolate our angle. Remember, in regular trig, the angle is the input. Inverse trig is going to swap that. So I'm going to do x is equal to the sine inverse of negative 1/2. All right, now up is I need to figure out, since the ratio is negative, where are my two answers going to come from? My two equations, basically. So the primary values come from the first and the fourth quadrant. So sign ratios are negative in the fourth and the third quadrant. So my primary value is going to come from right here. So negative 1/2, a triangle like that. And my secondary value is going to be mirrored across the y-axis over here. Again, a sine ratio of negative 1/2. So I need to know what this angle is. This is the secondary value. And my primary value is going to be right there in the fourth quadrant. So I am going to use my calculator because why not? I could use the unit circle, but in Khan Academy, you're going to have some weird numbers. So I'm going to be like, another way to write this is the sine, wow, forgetting some letters, sine inverse of negative 0.5. I'm going to use my handy dandy calculator. Did you guys watch Blue's Clues? Yeah. Okay. Sine inverse of negative 0.5. I think I'm in radians. So if I'm in radians, I'm going to divide out the pi to give me the fraction. It's 0.116666. So it's negative 1 pi over 6. So the primary value is negative pi over 6. So in the fourth, which is in the fourth quadrant. Okay. Yay, from the fourth quadrant, just like we thought. So we're going to use x is equal to the primary value, principal value, plus 2 pi n, since we're in radians. Okay. So I'm going to write x is equal to negative pi over 6 plus 2 pi n. This gives me all possible solutions from the fourth quadrant. Okay, you know what? You couldn't see any of that. There you go. Okay, so again, we have the principal value is negative pi over 6. So I took care of my fourth quadrant stuff. Now what do I do for the third quadrant? So for third quadrant, I'm going to use x is equal to pi, so 180 minus the principal value plus 2 pi n. And this will give me the angle in the third quadrant. Okay, so I'm going to do x is equal to pi minus negative pi over 6 plus 2 pi n. And x is going to be equal to, let's see, 6 over 6 plus pi n gives me 7 pi over 6, or I'm thinking it's one wedge past the x-axis, plus 2 pi n. So you can see right here, the secondary value is 7 pi over 6, which makes sense. It's in the third quadrant. We're good to go. The 2 pi n, remember that has to do with all of our coterminal angles. So this is all possible angles from quadrant 3. Getting lazy there. Okay. All right. The next thing. So we solve for all possible angles. That's number 1. Now we need to solve for all angles between negative 2 pi and 2 pi, basically. All right. So this is what we do. We're looking for all of the coterminal angles. So I'm going to take my equation, negative pi over 6 plus 2 pi n, and I'm going to use any integer. So right now, if I use the integer 0 over 6 plus 2 pi times 0, that cancels, giving me negative pi over 6. Is negative pi over 6 between negative 2 pi and 2 pi? Yes. So this is an answer for us. Okay, so we're going to do another one. Negative pi over 6 plus 2 pi, any integer bigger than 0. Okay, 1. So I'm going to add, instead of 2 pi, let's call this negative pi over 6 plus 12 pi over 6, giving us 11 pi over 6. Is that a value that's in between negative 2 pi and 2 pi? Yes. Okay, how about if I did it again, but with a 2 times 2? So if I add one more full rotation, I get negative pi over 6 plus, let's see, instead of 12, we're going to do is 24 over 6 pi, giving us 23 pi over 6. Is 23 pi over 6 in the first full rotation? No, that's greater than 2. So this one is outside of our domain. Okay. All right. So what I need to do now is test if I spun backwards one full rotation, would I still have an answer that works for me? Negative pi over 6 plus 2 pi minus a rotation. So we're going to multiply by negative 1. I get negative pi over 6 minus 12 pi over 6, giving me negative 13 pi over 6. I'm going to take these. 13 over 6 is greater, let's see, that's greater than 2. So I am not within the rotation, first negative rotation of my graph. So that one does not work. So I list my answers like so, because this is a mess. And be like, my answers are negative pi over 6 and 11 pi over 6. Those are the two values for the fourth quadrant, right here, the fourth quadrant, that are going to make, if I input 11 pi over 6 or negative pi over 6 in for x, it's going to give me a ratio of negative 1/2. Okay, so we got to do the same thing for the third quadrant. So check it out. I got the third quadrant angle here. I need all my coterminal angles. So what I'm going to do is go x is equal to 7 pi over 6 plus 2 pi times 0. That cancels, giving me 7 pi over 6. So I didn't add a rotation. 7 pi over 6, that's in between negative 2 pi and 2 pi. X is equal to 7 pi over 6 plus 2 pi times, let's see, if I go backwards a rotation, so multiply by negative 1, I get 7 pi over 6 plus negative 12 pi over 6. So 7 minus 12 is negative 5 pi over 6. That's an answer. If I try another rotation, 7 pi over 6 plus 2 pi times negative 2 rotations, that would be 7 pi over 6 minus 24 pi over 6. 7 minus 24 is negative 17 over 6 pi. 17, you can't see because I'm in the way. Okay, 17 pi over 6 there. That is greater than 2. 6 goes into 17 more than 2 times, so that is not an answer. All right, so I tried 0, that works, so I gotta try 1. So x is equal to 7 pi over 6 plus 2 pi times 1, giving me 7 pi over 6 plus 12 pi over 6, gives me 19 pi over 6. So is 19 divided by 6 less than 2? Okay, so my answers from the third quadrant are negative 5 pi over 6 and 7 pi over 6 because they are coterminal angles. Bam! They will give me a ratio of negative 1/2 when I use my sine ratio. All right, next up. Tangent ratio. Is it positive or is it negative currently? So the ratio is root 3, which is positive. Tangent ratios are positive in the first and the third quadrant. Where will your principal value be? That's right. It will come from the first quadrant. So now I'm going to go ahead and draw my little triangle there. I need to find the principal value. So I'm going to solve. The angle is x. So I'm going to do x is equal to isolate an angle, we use tangent inverse of root 3. Go ahead and pull out your calculator. And we're going to be like, whoa, calculator did not like that. Okay, tangent inverse of square root 3. All right, remember we divide out pi to give us our fraction of 1/3. So this is going to be pi over 3. Okay. All right, so the principal value is pi over 3. Actually, let's just go back there. Okay, so this is pi over 3. So how do I get my coterminal angles? Well, we love tangent because tangent only needs one equation to be able to solve for its secondary equation. So what we do is we just write the principal value plus pi n. Basically, if I add pi, I end up with my secondary angle. And then getting back to the original angle, you're just going to have to add pi again. So tangent's the best because it has one equation to solve for all of its angles that make its equation true. So I'm going to be like, the principal value is, so x is the angle, is equal to pi over 3 plus pi n. And this gives us our coterminal angles and all those angles that we needed to solve for in the other quadrants. Okay, so now we're going to, so this is the answer for the first part. So this is all possible angles. All possible angle answers from quadrant 1 and 3. All right, we're going to solve for the angles between negative 2 pi and 2 pi, with negative 2 pi being included. And I'm going to give you a faster way to solve for the angles. So you start with your principal value, and then you're just going to add whatever it says here. It says to add pi. So we're going to add pi to give us our next value. And then we're going to add pi to give us the next value. So I'm going to start with pi over 3, and we're going to add pi, which is 3 over 3. So we're adding 3 over 3. So that gives me 4 pi over 3. If I add 3 over 3 again, I get 7 pi over 3. And then 10 pi over 3, 13 pi over 3. If I go backwards, we need to subtract 3 pi over 3. So subtract pi, giving us negative 2 pi over 3, 5 pi over 3, negative 8 pi over 3, negative 11 pi over 3. I could do this for days. Okay, next. Which of these angle measures are between negative 2 pi and 2 pi? So all you got to do, the fraction 4/3. 7 divided by 3 is greater than 2. That one doesn't work. 10 over 3 greater than 2. 13 over 3 greater than 2. Not in our domain. All right, so negative 11 over 3 greater than negative 2. Doesn't work. Greater than negative 2. Negative 5 over 3, that's less than 2, so that one's going to work. These are our answers right here. That's it. When I input these into, so if I input root 3 is equal to the tangent of negative 5 pi over 3. If I type this into my calculator, guess what? What am I going to get? Root 3. I'm going to get root 3. Okay? So any of these answers would give me a tangent ratio of root 3. All right, last one for now. Okay, cosine. The ratio here is positive. Cosine is positive in the first and the fourth quadrant. So I'm going to have a principal value in the first quadrant, and then a secondary value from the fourth quadrant. So your calculator will always give you a principal value from the first and the second quadrant. I'm going to go ahead and write x is the angle. So I'm isolating x, so I'm going to use cosine inverse of root 3 over 2. Grab your calculator. And so I have a cosine of root 3 over 2, so that's going to give me, we'll just do it for funsies. Okay, cosine inverse of square root 3 over 2. You can use, oh, I broke it. I need some parentheses. Oh, I see what's wrong. Okay, so I need some parentheses right here because the root 3 is the only thing I want under the fraction over 2. Okay, now I'm going to divide out to give me 1/6. If you want, you can math enter that to double check. Okay, so the angle is pi over 6. That's our principal value. All right, so our principal value is pi over 6 plus 2 pi n. The nice thing about cosine is that the secondary equation is just the negative principal value, because you can see that these two triangles are a reflection of each other across the x-axis. So we get a negative, So negative pi over 6 plus 2 pi n. All right, all possible solutions from quadrant 1, all possible solutions from quadrant 4. Okay, so all possible solutions from Q1, all possible solutions from Q4. Okay, so now if I want to solve specifically for angles between negative 2 pi and 2 pi. You know what? When I say all possible solutions from quadrant 1, I'm saying that the domain is between negative infinity and infinity. So this is like if the graph just kept going on and on and on and on and on and on. Okay. So I'm going to use the trick I used last time because plugging in the integers takes forever. So I'm going to take the principal value, pi over 6, and I need to add 2 pi n to get my coterminal angles. So I'm going to add 2 pi, so the first 2 pi. So I'm adding, which is 12 pi over 6 in this case. So I get 1 plus 12 is 13 pi over 6. I'm going to, 13 divided by 6 is more than 2. So I am already outside my domain. Let's go ahead and work backwards. So we're going to subtract negative 2 pi, which is negative 12 pi over 6. So 1 minus 12 is negative 11 pi over 6. That's inside. If I subtract another 12 pi over 6, I get negative 23 pi over 6, which is way more than 2. So I'm going to cross that off. So negative 11 pi over 6 and pi over 6 are the only two angles within the domain of negative 2 pi to 2 pi that will give me a ratio of root 3 over 2 from the first quadrant. That was a lot. All right, second, from the fourth quadrant, we're going to start with x is equal to negative pi over 6, and we're going to add 2 pi n. So negative pi over 6 plus 2 pi. So again, adding 12. So I get 11 pi over 6. I'm going to add 12 again, giving me 23 pi over 6. Too big. All right, so we're going to subtract 12. All right, so 1 minus 12 is negative 13 pi over 6, which is too big, or too small, actually. So the two angles that work are negative pi over 6 and 11 pi over 6. That's it. So the thing to remember is that all the different trig ratios have different rules, have different little angle setups here. So depending on which inverse trig ratio you're using, those are the rules you're going to use to solve for the primary and secondary angles, or the principal and the secondary angles. Okay?